Hello, my name is Stacy Wright, and I would like to welcome you to the Designing for Wildfires training series presented by the Federal Emergency Management Agency's Building Science Disaster Support Program. This is part one of Module 2 by the Marshall Fire Mitigation Assessment Team, or MAT, and focuses on community planning. In this training series, the MAT hopes to expand knowledge of wildfire vulnerabilities in the built environment at different scales, from the community and neighborhood level to the subdivision and individual lot scales, and discuss resources and best practices. This training is part one of Module 2 in a series that includes 5 modules. Darlene Reaney and Amelia Pluto will guide you through this module. When you finish part 1, be sure to check out part 2 as well.
So as with any type of wildfire risk mitigation or even understanding the wildfire challenge in the built and natural environments, we really need to be thinking at planning and mitigation at various scales. So anything ranging from the individual lot scale or building parcel level up to the neighborhood or subdivision scale, and then more broadly to the community scale and even regional scales. For community wildfire planning, there are a number of topics and concepts that we need to think about when we're trying to not only understand wildfire threats to our communities, but also to be able to better mitigate against those and develop strategies to help reduce those risks. On this slide, we're just showing a number of those concepts or topics that we'll be touching on within this presentation, but there are certainly a lot of others out there that we can reference within the FEMA products from the Marshall Fire. So before we get into these different, concepts of analysis and understanding, one of the first fundamental components to planning for wildfires, like any other hazard and at any scale of application, is to first understand the potential hazards and risks in and around, say, a development site or a neighborhood at sort of larger landscape levels. So that might be at the city level, a sub-city level, or a regional scale. And this process typically starts with first consulting state and local level wildfire hazard maps. So for California, this would be the fire hazard severity zone maps produced by CAL FIRE, as well as any other local fire hazard maps from county or even local level fire agencies. In other states or jurisdictions, these types of maps may be provided by the state fire marshal, the state forestry department, or other equivalent agency. But in many contexts or many cases, state level maps may not exist, although that is rapidly changing. In these cases, consulting a wildfire behavior specialist would be the recommended approach. And assuming these maps are available, they help us as designers, planners, or AHJs to know when WUI code provisions would be triggered. So while this is explicitly the case in California, it may not be true for other states. It should be noted that most wildfire hazard maps only really provide you with information about the potential severity of a wildfire, given various environmental settings, whether that's topography, weather, vegetation. And they typically do not capture what we'd call true risk, in that they generally do not include frequency or return period information, or even potential impacts or consequences in the built or natural environments. So this is really where we as designers, architects or planners, or other design professionals or wildfire risk mitigation professionals really need to help inform this understanding. So we should, as designers and planners, should really understand what buildings, structures, and other types of values are in the area or proposed development site. And so we should know characteristics not only of the existing conditions, but also the proposed uses, demographics, characteristics of people that are going to be using the space, the buildings, or area. And once we have that understanding of both the hazards and the risks at a larger scale, then we need to evaluate the same types of concerns, hazards, risks, and vulnerabilities more at the localized scale that we're planning at. And this may be informed again by state or county level resources, as some agencies or even local fire state councils may have performed more detailed or granular level hazard mapping. But in many cases, we recommend that you consult with a wildfire hazard specialist to provide this local level analysis. So finally, we did want to point out that in addition to all these other mapping resources, there's also a number of other kind of local level community planning documents that have a wealth of information generally on wildfire risks and threats within the area. And this can include, general plans or comprehensive plans, zoning maps, community wildfire protection plans or CWPPs, along with a number of variety of other types of planning documents that are listed here. So in addition to having a comprehensive understanding of hazard and risks at various scales, as designers, planners, or authorities, it's also important for us to consult state and local level wildfire building and fire codes. And in the absence of those, there's the International Wildland Urban Interface Code, or IWUI code, as well as NFPA 1140 standards that can help inform more specific design criteria at a local level. And so, as we would typically do for other types of fire safety concerns in the built environment, really understanding the local requirements, policies, and provisions of the local fire department, building department, or other agencies that may inform fire safety planning. We should also be looking at those local considerations. So that can also include not only local ordinances, but any type of locally developed guidance documents, having an understanding of any specific planning processes and review processes at the local level, as well as any types of pre-approved alternates or mitigation measures that would be relevant in the specific jurisdiction. So one other sort of key consideration that we also need to understand and apply for wildfire risk mitigation is to have better understanding of the other types of hazards that may be relevant in the particular context in which you're working, in addition to any other types of performance objectives that may be desirable for the site or the community at large. And so this, we call, I guess, a multi-hazard understanding or interactions is a critical piece to designing safer, more resilient communities, as we obviously don't want there to be a potential conflict whereby a mitigation strategy for, say, wildfire hazard doesn't exacerbate another hazard or performance goal. So one example of this multi-hazard consideration that we observed in the Marshall Fire was the presence of drainage ditches that were integrated into the community design to help manage rainfall and to prevent flooding. And you can see some examples of these drainage ditches from the Marshall Fire in the upper right-hand corner, as well as another example in a different community on the bottom right corner. So during the Marshall Fire, these sort of drainage paths or ditches not only provided this benefit of having flood management or water management, but they also presented a location in which there was increased fuel loads from the accumulation of biomass. And so once the fuels in this space were ignited, they also ended up providing this avenue or pathway for fire to rapidly spread into the community, as well as increase certain types of hazard exposures for structures and the built environment along this pathway. So ultimately, as designers and practitioners, as well as AHJs, just need to be more mindful of these potential conflicts, and therefore sort of better inform any type of mitigation practices that we might introduce for wildfires, such that they're complementary and certainly not in conflict with any other type of hazard that would be relevant for the space or for the community, or other types of performance goals that might be desired by a site or a community.
So now we're gonna shift and dive a little deeper and talk about specific considerations at the subdivision level. So one key subdivision planning concept is the siting of the proposed development on the landscape. So this is really about making sure that when you are evaluating and selecting potential sites, high hazard areas are being avoided. So these are areas like narrow canyons and gullies, saddles or narrow mountain passes, as well as areas adjacent to or located on steep slope. And multi-hazard considerations come into play here as well. These are areas that should also be avoided if there is a risk of landslide in the area and possibly other hazards as well. And while these general rules of thumb are helpful, the best way to understand potential hazards at that development or neighborhood level is doing a site-specific hazard and risk analysis. This is important to provide a higher level of granularity, highlight potential flow paths to and through the neighborhood, and then highlight areas of localized fire intensity due to the topography and built environment. The importance of this type of analysis was really highlighted in the Marshall Fire. Many of the neighborhoods that were severely impacted by the wildfire were not on ridges or hilltops or saddles, but we did see that many of the heavily damaged neighborhoods were located along what got termed in the field fire superhighways. So that is, many of the impacted communities had design features such as green belts, drainage channels, as Darlene mentioned, and other open spaces that served as a direct path for the wildfire to spread from more rural areas where it initiated into and through the suburban environment. So these superhighways provided not only a continuous fire flow path, but an abundance of vegetated biomass and unique topographic conditions that increased fire severity and facilitated rapid spread of fire along these paths. So this translated to more severe fire conditions for the structures that were located along this interface and also at the head of the fire flow path. So in some situations, we may have the ability to avoid siting a development in high-risk topographies, but in many instances, this may not be possible due to various site constraints. So this next set of slides provides some recommendations for better planning and designing to reduce exposure to high-risk features that might be present. So first, we're going to talk about ridgetop developments. And in this case, a minimum of 30 to 100 feet of setback from the downslope side should be provided. And higher setbacks are typically needed depending on the steepness of the slope and the vegetation present on the slope. And so this is an instance where consultation with local fire and WUI experts can provide more guidance. And then there's also information available on defensible space and long-term vegetation management in NFPA Firewise and other local WUI fire ordinances. If this 30 to 100 foot setback is not feasible, we have some additional recommendations, providing 30 to 100 feet of fuel modification on the proximate slopes. You should consult with local fire departments or AHJs for site-specific guidance and local requirements. In some cases, fuel modification greater than 100 feet may be necessary. This can be 200 feet or more in areas such as LA County and Orange County in California. And then we also recommend that all structural hardening measures are provided and additional fire resiliency measures are included, such as 1 hour fire-resistant exterior walls on structures abutting that setback. Another condition that may be encountered is a development site may be located adjacent to or interfacing with large, uninterrupted wildland and unmanaged open spaces. This was a common situation that was observed following the Marshall Fire. In these instances, the fire was able to travel unobstructed through this open space before it reached the perimeter of the neighborhood, where it transitioned from a wildland fire into an urban conflagration. So in this context, where a development is within 100 feet of wildland or open space, some recommendations include providing fire-resistant fuel breaks, integrating features like fruit orchards, irrigated landscaping, golf courses, agricultural belts, or other low fire risk uses. Another option is to provide a 6-foot solid, non-combustible property line wall or fence. This is generally more effective for grass and shrubland landscapes. And then on the development side, to prioritize providing structural hardening measures for structures that are at the interface with that wildland vegetation, and at the very least on the sides of structures that are within 100 feet of the interface. So a little bit more detail about what those structural hardening upgrades could look like. This could include exterior walls, windows, vents, and other features of the home to be non-combustible and fire resistance rated, for example, 1 hour. And there is additional detail about this in following modules. Another recommendation or sample upgrade is 5 to 10 feet of non-combustible landscaping around the home. And then, of course, it's important to integrate drainage and flooding mitigations as well for that multi-hazard consideration. A similar condition that often is overlooked is that a new development may be adjacent to an existing development that was not designed to WUI codes. And therefore, that development could present a potential fire hazard to the new development, as the structures may be more vulnerable to ignition and pose that potential for structure-to-structure fire spread. In this case, we provide similar recommendations to those we just discussed. So evaluating specific hazards and the proximity and potential source of ignition, installing a non-combustible property line wall, and prioritizing structural hardening features for the buildings around the perimeter that are within 30 feet of other developments.
Okay, so we're just going to shift gears a little bit now. Amelia was touching on sort of more community or neighborhood scale types of considerations that would need to be adopted or evaluated to provide increased wildfire resiliency, particularly related to where a development or a property is located relative to common topographic hazards or even existing urban environment hazards. So before we get into more, I guess, building specific or configurations of neighborhood design, we did want to touch on 2 key concepts that get talked about or used in order to help mitigate wildfire risks. Amelia touched on a couple of these or on both of these previously, but we did want to spend a little bit of time to just level set on in terms of definitions and what these 2 main concepts are, because they're pervasive throughout all wildfire risk mitigation guidance and codes and standards. So the first main concept that we talk about here and in other literature and other guidance is the concept of structural hardening, which is essentially describes, the fire resistive construction materials of a building or structure, the details of how the various components are joined together or fit together, as well as other types of systems that can be used to help limit not only ignition of the structure, but also fire spread along the individual building and then fire spread between structures. And so a variety of different types of components and systems are available to help with structural hardening. And typically they're organized or thought of from the top of the structure down to the foundation. So some example structural hardening considerations or measures include things such as Class A roof covering, vent protection, use of non-combustible facade materials. So you can refer to existing WUI codes and guidance documents for a lot of details about the various types of components, systems, and features related to this. The MAT, so the Mitigation Assessment Team guidance from the Marshall Fire also highlighted some new considerations along structural hardening, in particular detailing at joints and edges. So the other kind of main concept that is oftentimes discussed and used to help reduce wildfire threat at the sort of building and parcel level is the concept of defensible space. And so this is the area around a building or structure where the location, selection, and maintenance of the vegetation, as well as other man-made fuels, are restricted. And this is to help limit fire from spreading from the wildland space directly up to the building. And so again, there's several resources that are available at a national level. And in some cases, there's augmented guidance to the specific local jurisdiction or environment in which you're working, but this can be oftentimes limited in other places. And typically defensible space is organized around what they call fuel modification zones. There's still some inconsistencies in how these zones are identified, but a common delineation of the zones is 0, 1, and 2, where 0 typically encompasses the distance from 0 feet from the structure out to 5 feet from the structure. And typically that zone is considered this either non-combustible zone or an ember resistant zone. And then the subsequent zone 1, is typically from 5 to 30 feet away from the structure, where it can also be known as the lean, clean, and green zone. And then zone 2 is typically 30 to 100 feet out or even more. And this is this sort of interaction, this wildland fuel restriction zone. And so each of the zones are essentially set up to have more and more restrictions on the type of vegetative and man-made fuels as you get closer to a particular building or structure. In many jurisdictions, or in some jurisdictions, there's oftentimes prohibited and approved plant lists to help inform the type of vegetative choices that you may want to enlist around a particular building or structure. There's also some guidance related to how you can arrange these different types of plants and trees in the different zones. And also associated management practices for long-term maintenance and sustainability of the vegetative fuels. So given those general concepts, we'll now go into some other type of spatial configurations that you may encounter when planning for a community or neighborhood. One consideration is housing density. So in this particular case, we're just really simplifying it down to these two kind of basic conditions. One, where we're going to call traditional or lower density building footprint. And what we're really meaning here is the more, I guess you could say, traditional type of suburban style housing, where you have a single home and you have sufficient yard space around individual homes such that you have more than 30 feet on all sides. And then we have its other condition, which may be more common as you get into more urban development, where you have clustered or higher density building footprints. And in these conditions, you may have less than 30 feet of separation around each individual building. Okay, so lower density housing footprint. This is sort of what we call traditional housing design, where you have sufficient side yards around each individual building. And most of the existing WUI codes and standards are really designed around this, what we can also call an ideal parcel. And so the understanding or the assumption is that you have 100 feet of space around your building for defensible space, and at least 60 feet separation to other buildings. But as we all know, even with lower density housing footprints, we don't always have 100 feet of defensible space. And in many cases, we may not either have 30 feet of separation to the property line, or in other words, 60 feet to approximate buildings. So in the condition where buildings don't have 100 feet of defensible space within its own property lines, we recommend the use of this concept called communal defensible space. In this case, proximate buildings essentially must share this common defensible space zone and maintain the 0 to 3 or 0 to 2 zones to provide protection for the whole collective of buildings. And so there's a need to ensure that all plants and trees and landscaping design meets these fire resistant guidelines of the local area for all the buildings collectively, as well as having long-term maintenance plans in place to not only maintain what vegetation and non-vegetative fuels, how those are managed, but where possible to implement landscaping and plant choices that would require a minimum amount of upkeep, since this is a communal space and it can be challenging to ensure long-term cooperation amongst neighbors. So in the condition where we have low density housing and we do not have a building setback of more than 30 feet to adjacent structure, this particular spatial constraint is actually one of the main vulnerabilities that we see in wildfires. And this is because if one structure were to ignite and is within 30 feet or 60 feet of another structure, then both structures or the adjacent structure is more vulnerable to structure-to-structure fire spread. And so what we saw in the Marshall Fire and what we've seen as well in Maui fires and other recent wildfires, that structure-to-structure fire spread is one of the main vulnerabilities once a wildfire enters into a more suburban and urban environment. So in this case here, you can see the image on the right, which is showing an example of a neighborhood in the Marshall Fire, where you see on the far right a plan view of a typical sort of lower density housing development with a lot of common vegetation in between housing. And you can see that the spacing between structures are also quite close. The image on the left is showing just an example of the side yard that is shared between two adjacent homes that are anywhere from 5 to 8 feet to the property line and less than 30 feet between each structure. So in this case, as you can readily see, both homes are vulnerable not only to spot fires from embers that could ignite the fuels on either side of their property line, but also in the event that one of these structures would ignite, that it could easily spread to the adjacent neighbor's building. So in these conditions, the recommendation is to provide enhanced structural hardening where you have structures close together. So this would include things like a 1-hour fire resistant rating of the exterior building envelope, particularly on the face or the facade that's facing the adjacent structure, reducing the number of windows if you're in a design scenario and not necessarily existing scenario, increasing this sort of zone 0, this non-combustible or ember resistant zone from 5 feet up to 10 feet, and including in a 6-foot tall solid non-combustible wall along the shared property line.
That wraps up part 1 of module 2 of the Designing for Wildfires training series presented by the Marshall Fire MAT. Next in the series is the continuation of Module 2, as Part 2 dives deeper into community planning concepts for wildfire. On behalf of FEMA's Building Science Disaster Support Program, thank you for taking time to review this module, Part 1.